Hi everybody, I'm Mr. Adam. Today we are looking at Computer Science A-Level Paper 3 and the chapter is Boolean Algebra and this one is the part 1. Okay, now what we are going to study here, we have to understand Boolean Algebra. We have to understand also De Morgan's law and how to use the De Morgan law and also how to simplify Boolean expression using Boolean algebra. Earlier we were simplifying using Carnot map, but now in this chapter we will use Boolean algebra to simplify Boolean expression. Now let's look at these identities, the rules. You have to know the N rules, O rules. Okay. Now N rules is A multiplied by A is A multiplied by A dash is 0, A multiplied by 1 is A multiplied by 0 is 0. Then we have the O rules. Okay, A plus A is A plus A dash is 1, A plus 1 is 1, A plus 0 is A. And also we have the De Morgan law, these two are the De Morgan law. And this one is the consensus theorem. So again here you have the identities, okay, the product, the sum, these are commutative law, associative law, distributive law, consensus theorem, and De Morgan theorem, the famous one. You have to remember these rules by heart. And also the double negation. It means A dash then dash is the same thing as A. We'll look at it in more details. Now, let's look at the Boolean identities. Okay, the inverter, also known as the NOT gate. Okay, A dash in 0 becomes a 1 and a 1 becomes a 0. AND gate, you multiply 0 times 0 is 0, 0 times 1 0, 1 times 0 0, 1 times 1 1. Okay, and the OR gate, you add 0 plus 0 0, 0 plus 1 1, 1 plus 0 0 1, 1 plus 1 is 1. Now next is other simple identities. The XOR gate. Okay, the XOR gate, when the two inputs are same, the output is 0. When the two inputs are different, the output is 1. Same is 0. Then you have the NAND gate. Okay, this is a NAND gate. You multiply and then you inverse. So 0 times 0 0, inverse is 1. 0 times 1 0, inverse is 1. 0 1 times 0 0, inverse is 1. 1 times 1 is 1, inverse is 0. And also you have the NOR gate. You add A and B and then you do the dash. 0 plus 0 0, dash is 1. 0 plus 1 is 1, the dash is 0, here 0, here 0. Now what is I have to show you something. Okay, let's assume A is 0 and 1. A dash becomes 1 and 0. Now A plus 0 means A plus 0, 0 plus 0 is 0, 0 plus 1 is 1. So A plus 0 is A, it's the same thing. This is how we got A. Okay, then A plus 1, this is A. You add 1 to it, you get 1 1. So A plus 1 is 1. Okay, next A plus A. So A, you add A again, is the same thing. So a plus a is a. And now a plus a dash. Okay, this is a. This is a dash. A plus a dash is 1 and 1. Plus 0 plus 1 is 1. 1 plus 0 is 1. So a plus a dash is a. Now these are called the sum. A plus 0 is a plus 1 is 1, a plus a is a plus a dash is a. Now we look at the product one. Okay, a times 0. So this is a times 0. A times 0 is a. A times 0 is a. Now a times 1 is 1, and a times a is a, and a times a dash is a. Now a negate double negation, a dash, a dash, then dash, it's a. You can try it. Now this sum and the products or the identities, we have summarized it in this table. So this is the product, and this is the sum, and this one the product. So a plus 0 is a plus 1 is 1, a plus a is a, and a plus a dash is 1. And a times 0 is 0, a times 1 is a times a is a times a dash is 0. Now we are done with these 4 identities plus 4, so 8 identities we are done now. Now there is something called a commutative law, okay, associative law, distributive law, and the De Morgan law. So what is commutative law? A times b is the same thing as b times a. A plus b is the same thing as b plus a. Now what about the associative law? We can put a bracket here. A plus b bracket c is the same thing as a plus b plus c in bracket. The same thing applies for multiplication. We can put this in bracket or this in bracket. It's called the associative law. Now distributive law, a times b is ab, a times c is ac, and plus in the between. Now distributive law, we also have this one. Okay. Now De Morgan law is simple. A plus b dash is the same thing as a dash plus b dash multiplied with, okay, and a multiplied by b dash is the same thing as a dash plus b dash. So if it's multiplication, here comes summation. If inside it is summation, here it comes multiplication. So these identities you must know by heart. You must be able to derive it. Okay, now let's go through it quickly. Commutative law, a plus b is the same thing as b plus a. A multiplied by b is the same thing as b multiplied by a. We have proved it using the truth table. You can see these are the same. Next, associative law, you can see. Okay, we are done with this. We have already explained this. Okay, this is associative law, and we can prove it here. This one and this one is the same. Now next is our our distributive law. Okay, bracket can be here. Distributive law, this one and this one. Sorry. Distributive law, okay, this one and this one. Okay, we are done with this already proof. Double negation, we are done. Okay, so maybe we should put a dash again. double negation is the same thing as E. Next, what is De Morgan law now? De Morgan law is very simple, like E multiplied by B whole in dash is the same thing as A dash plus B dash, and we have proved it using this one, so you can check the truth table. We have proved it. Next is, let's say, E plus B dash, it's the same thing as A dash multiplied by B dash. You can see they have used this, and we have proved it using this one. So that's right. Have a look at it, go through it carefully. Next, let's take this example. Using the De Morgan law, that is E dash multiplied by B dash whole sub dash is the same thing as E dash plus B dash. Dash and dash. Wait, yeah. So dash dash will cancel, dash dash will cancel, we'll get E. We'll get E plus B. E plus B. Wait, let me check. Okay. Here is this. Let's go right. Okay. So this is what is given. This is what we get with De Morgan rules, and with the rule of double negation, get this one. Okay, we have to work it out again. Now this one also you can try it. You're supposed to get an E. This one, work it out, you're supposed to get an E. And this one you can try it, you're supposed to get an identity 1. This one, try it, you're supposed to get X. And the last one, you try to solve this and get this one. Oh, sorry, this one. Now for this one, you work it. Answer will be this one. Okay, this one you work it, you get B. This one you work it, you get B. Try to work it, and you can contact me if you get difficulty. And this example, this one, try to solve it. Try to solve this. This one, this A times B. Now try this one. Get A. Try this one. Get A. Answer yes. I'll work it through. Okay. This is a very interesting example. You work it out, and you're supposed to get this. Example 3. You try to work this out to get this answer. Now this one also is interesting. F, try to reduce it, and this is the final answer using the following rules below. Second example, you try simplify using Boolean algebra. and there are 4 possible answers: 1, 2, 3, 4, using the following rules. In the third example, try to simplify this Boolean expression step by step using the following identities. You will get this as the answer. Okay, we came to the end of this chapter, so good luck. Bye bye. Take care.